Well, good evening, everyone, and welcome to the Brian Crombie Radio Hour on Saga 960. So, one of the topics that I've been really interested in is something called the Fourth Industrial Revolution. And we've had a couple of shows on this. And the Fourth Industrial Revolution is often thought of as having a couple of different components: advanced manufacturing, artificial intelligence, and Internet of Things. And I wanted to reach out to a friend of mine who actually is an expert in this area, particularly artificial intelligence, and find out, what it's all about and is it actually happening. And some people think that this fourth industrial revolution that may be occurring right now is as impactful potentially on society as the first industrial revolution that happened like 250 years ago, which was sort of, oil and gas and steam power and manufacturing, sort of the industrial revolution. And then the electric revolution that happened about 150 years ago, which obviously changed manufacturing fairly dramatically and powered our cities and things like that. And the information science revolution that happened 50 years ago. And so one thing is that these revolutions, if they're actually that material, are happening more rapidly. And when you think about, the impact of information technology and how it's changed absolutely everything, some people think that this sort of digital economy, this fourth industrial revolution, is going to have a comparable material impact on all of our society. And so I want to introduce you to Ilona Urbaniak, who is a professor, an assistant professor at the University of Krakow, University of Technology. And she's interesting because while she's in Krakow, she's a Canadian, and she graduated with a PhD in applied mathematics from the University of Waterloo. She's currently an assistant professor in the Department of Informatics. So we'll have to figure out what informatics is. She's in the Division of Data Science, and she's an assistant professor, and she teaches courses in artificial intelligence. So kind of interesting. So Dr. Ilona Urbaniak, how are you?
Thank you very much, Brian, for such a long introduction. Yes, I'm doing well. How are you?
Very well. So tell me first a little bit about your background. So you graduated University of Waterloo Applied Mathematics, and how did you then go from there to the Krakow University of Technology?
So my research interests are in medical image analysis, and this is what I was doing for my PhD. And after I graduated at the University of Waterloo, I was working as a postdoc at a company, and we were actually, it was a software company, medical imaging software company. So it was quite interesting and very much related to my research. After that, I got an offer from a Polish university, which is Krakow University of Technology, to be an assistant professor there and continue my research and teach, which is great. And I'm still here. So it's been 2.5 years since I moved to Krakow from Toronto.
And you're Polish, but you're Canadian. Do you teach in Polish or do you teach in English?
I teach in both languages. We have this excellent program called Erasmus. It's an international program for international students. So right now it is online teaching. So yes, it's actually both in Polish and English. Yes.
Fantastic. So let's take a step back if we could. Tell me, what is artificial intelligence?
Yeah. So what is artificial intelligence? There is no one agreed upon definition of artificial intelligence, and even AI researchers have no exact definition of AI. And this field is actually rather being constantly redefined. And what does it really mean? What does it mean, artificial intelligence? So it actually means artificially making a computer intelligent. So that's the first thing that comes to everybody's mind when we think artificial intelligence. So, for example, the theory and development of computer science systems able to perform tasks that normally require human intelligence. And for example, you can think about visual perception or speech recognition, decision-making, translation between languages. So in general, AI research is defined as the study of intelligent agents, which means any device that perceives its environment and takes actions that maximize its chance of successfully achieving its goals. And what are these goals? Actually, we can ask, and these goals are sense, reason, act, and adapt. And actually, maybe it will be more proper.
Hold it.
It will be more proper. Yes.
No, hold it. So sense, reason. What were the four?
Act, and adopt.
And adopt. But so that's interesting, because that really does give a very interesting description of what intelligence is. So what you're saying is that a computer that is unintelligent, it's just doing something. That's the intelligence comes from the human. But what an artificial intelligent computer needs to do is sense, act, reason,
and adopt. So let me just
act and adopt.
Concentrate on the two properties that are actually most characteristic to AI. And what we should think about, these properties are autonomy and adaptivity. And what do I mean by autonomy? So what is autonomy? It is the ability to perform tasks in complex environments without constant guidance from a user. So that's autonomy. And what is adaptivity? That's another property that is characteristic to AI. So it is the ability to improve performance by learning from experience. And learning from experience in this case could be learning from historical data. Okay, so these are the two main properties. Instead of course, thinking of like an exact definition of AI, we could think of it as what kind of characteristic properties it has. Yes.
Well, that's interesting. So it is autonomy and adaptivity.
Yes.
You got to be self-sufficient, and you got to be resilient and adapt. That applies to people.
Exactly. You got to be able to learn from experience, as we do. So this is how we want to artificially make a computer intelligent.
Dr. Urbaniak is joined us from the Crombie University of Technology. She's going to talk a little bit more about artificial intelligence, but we're going to take a break first. Stay with us. Welcome back to the Brian Crombie Radio Hour. We're chatting tonight with Dr. Ilona Urbaniak, who is an assistant professor at the Crombie University of Technology, and we're talking about artificial intelligence. And I'm very interested in how AI, artificial intelligence, is going to change, what we do. And so, Dr. Urbaniak, I wonder if you could tell me, what are some of the applications of AI?
So actually, we can let's talk about the areas, and then maybe some specific examples of the areas of applications of artificial intelligence. And I think we can divide them into three main areas, which is, for example, content recommendation. For example, here we can talk about online advertisement, music recommendations on platforms. And we talk about personalized content on search engines, for example. And we can talk about self-driving cars, and where the systems that are involved, the AI component is computer vision and decision-making. And here, similar technologies are also used in flying drones or delivery robots. Another area.
Let's talk about some of these. It's fascinating. So you talked about recommendations for music. So this is interesting, and I've seen it on book websites as well. And what is happening so that the computer is learning what you like, learning what other people like, but not just sort of making the recommendations. It's learning whether those recommendations actually work, whether you make purchase decisions based on them. Is that correct?
Yes, of course, there are many different ways and algorithms this can be done. But maybe a good example of this kind of thing is a project that I could describe. I'll try to talk about it in non-technical terms. I am currently involved in a project, fake news detection. It's kind of similar, but let me just describe how that could work. That kind of engine, fake news detection. So, for example, you have an article on the internet and you would like to know whether it's fake news or a fact. So how do we do this? So here we work with actually many people on this. This is a huge project. And it's so interesting because it has 3 independent modules. And the first module actually, it uses the natural language processing. It's a natural language processing unit. And it gives us a prediction whether a given article based on the content is fake news or not. Okay, so that's one module. Another module is another independent module. It tells us about the graphical content of a given article. So graphical content being an image, whether it has been manipulated or not. So our engine will be able to detect whether a given image that is included in the article has been manipulated or not. And the third independent unit will actually deal with the source of that information. And we will combine the 3 independent modules into a unit which is a hybrid unit, and it will take into consideration those 3 and make a decision based on the 3 independent engines. So it's a quite interesting project. So basically, having an article on the internet, first, if it goes through our engine, it will help the final reviewer to make the final decision about the article. So this is the usage, the future usage of this particular system that we're working on.
So then what are you going to do?
Quite interesting.
Is this something that you would then sell to a newspaper publisher, that they would evaluate what news they put on their website, or what's the use of it?
For example, or even if you, Brian Crombie, would like to find out whether a given article is fake news or not, you could use our system, our engine, to give you, for example, a yes or no or a probability. This is still an ongoing project, so this is just I gave you a description. So, for example, it could be used by an individual user or by companies. Yes, or give recommendations to reviewers making the final decisions later.
I think this is a huge potential benefit, particularly for all these people that are getting their information through social media, all these conspiracy theories, et cetera, that are floating around. And I think that too many of us are living in these echo chambers where we only get information from the sources that we're guided to through whatever the algorithm was on Facebook or whatever website we're on. But if we actually had something that we could evaluate and know whether the news was real or fake, that would be hugely beneficial.
Of course, it would be very beneficial. And also, I would like to add here that you see the internet looks more or less the same, and in terms of content looks very professional these days, and that's why it is very difficult to distinguish whether it is fake or not. And it's one of the problems, because all the tools that are being used to create websites are very easy to use, and they look quite professional. So yeah. So another area of AI is, I don't want to skip it because it's very important and I don't want to forget about it, is image and video processing. And in this case, of some like particular examples, face recognition, or for example, we could generate or alter visual content. And so also we could have some applications from customer to government applications, for example, passport control, or here, if I may talk about this interesting project that I'm thinking of. Recently, a master's student has contacted me, and she's actually just finished her master's in artificial intelligence, and she uses a neural network to generate MRI images of 3 categories, which have brain tumor that is malignant, benign, or there is no pathology. How interesting is this? And she can generate these.
Hold on. I apologize. We got to slow down here. You said neural network. What is a neural network?
Okay, so so that's okay. In neural network, I would like to talk about first about machine learning, and then I will talk about a neural network, which actually is described in a deep learning algorithm, and then maybe we can. It's inspired by the human brain.
Okay.
So it's a structure that how can I say it, where neurons are the core processing units of the network. It's a sophisticated and mathematically complex evolution of machine learning algorithms, but you skipped from, I wanted to talk about machine learning first before I go onto deep learning. So yes.
Okay. Then. So tell me, what is machine learning then?
So yes, so machine learning in general, we can think of it as systems, machine learning as systems that improve performance in a given task with more and more experience or data. Basically, here computers learn from data. So basically, we use algorithms to provide the computer with the ability to automatically learn and understand without being programmed again. And so what they do, they recognize patterns in the data and make predictions once new data arrives.
Okay. So that's
now,
machine learning.
That's
and then you said the next level is deep learning. So what's deep learning?
Is a subset of machine learning, and it is one of the ways of executing machine learning. And this idea has been inspired by the human brain, a human biological neural network. So basically, as I said previously, neurons here are the core processing units of the network. And of course, it's a more sophisticated and more complex, mathematically complex evolution of the bigger area, which is machine learning algorithms. So deep learning describes algorithms that analyze data with a logic similar to how a human would draw conclusions.
Okay, and
so for example,
go ahead.
You take data. They take data. They train themselves to recognize the patterns in the data, and they predict the output of the new set of similar data. Yeah, so that's how.
Okay, so what you had talked about was this person that was doing this MRI categorization and was using neural networks to categorize the MRIs in 3 different areas. So tell me why that is so interesting. Why is that such a extreme example and good example of artificial intelligence and deep learning and neural networks?
So first of all, she is not just categorizing, she's generating MRI images. And the database that she's generating could be used in different studies. So for example, why that is useful for me, because my area of research, I specialize in the quality of medical images. And recently, one of the projects, and why that is useful, I will tell you in a moment. But what she has done, and why I will be able to use that in my research. But for example, one of the things that I've been doing is that, for example, using machine learning algorithms, I am able to. We are able with my assistant right now. This is what we're working on. One of the most recent works. We're able to predict with a very high accuracy whether a given image, the strength of the magnetic field of a given image, the way it was acquired. So I'm talking about MRI images. So that's just some. I don't want to get it. I don't want to be too technical. So basically, this MSc student, she has, going back to the generated set of MRI images. So she is able, using a neural network, to generate a set of images, MRI images, categorized into 3 groups: brain tumor, malignant, benign, and no pathology. And those images, for example, could be used by me in a study to train another algorithm to, of course, make other inferences, to make other predictions, and to help radiologists with their daily work. This is my interest. Beginning with my PhD, this is what I've been inspired by, how radiologists work and how these images, what happens to them, what irreversible operations they must go through in order to be displayed to the user, for example, in this case, a radiologist. So there's a lot to talk about there, and maybe I don't want to get into details, technical details, but it's, for me, it's always has been a very inspiring and interesting topic. So quality of medical images, yes.
You know, you and I have talked about this before, and I was exposed to a study that was done by, you know, with IBM Watson, that was taking a look at radiology images and compared IBM Watson's ability to find cancer versus typical radiologists. And the answer was, number one, even initially, and I guess this would be in the way that you were talking about it, just in machine learning, in the first aspect of artificial intelligence, the IBM Watson was as good as the radiologist on average all day long, but really good later on in the day. And so therefore, when radiologists got tired, IBM Watson obviously didn't get tired and was just as good all day long. But then after time, when the radiologists fed back in their information about whether they actually found the cancer, and then they had other information that was coming in regards, IBM Watson learned from that process. And I guess that would be comparable to your explanation of deep learning or neural networks, where over time, the computer got better. And after that process, and that process took only you know, a couple of weeks, IBM Watson was far better than radiologists, because it learned it learned from itself and learned from the experience, and it learned from the benefit of interacting with the human radiologists, and it became really good. Now, they still submitted all of the reports to the radiologists to confirm, but it ended up being a far better way to analyze radiology reports.
Yes, so let me comment on this. Of course, in the healthcare services, so AI is used in tasks of diagnosis and even treatment recommendations. And yes, of course, AI system, and has achieved actually a breast cancer detection accuracy, which is comparable to an average breast radiologist, which is amazing. Yes, of course, it is amazing. And of course, with more data, because of course, the system will have even achieve a higher accuracy. But why it is possible? It is possible because a computer is able to analyze big data sets, and this is the ability that humans don't have, and it doesn't get tired. So yes, of course, and AI is of course helpful in many different areas and aspects of our life, and of course it's making our life easier, and it offers productivity, and because it can make faster calculations and solve more complex problems. So this is quite inspiring, and of course,
you know, it's interesting, Dr. Urbaniak, because it not only is applicable to things like radiology reports, but it is applicable to, you know, your choices on Spotify and your choices on Amazon, where it learns what number one you like, but then also it learns what people like you tend to like, and they'll give you recommendations. And some people complain about privacy and stuff like that, but you know what? Most of the recommendations that I get provided to me are really good recommendations. They learn what I like.
Yes, of course. It also, I should also mention that AI, it could improve life conditions. And for example, in airports, you don't see this probably right now on many airports, but there are artificial robots which lead you to find your route easily. So we also talk about technological and smart housing. Smart houses are being built. There's so many different areas where AI can be applied, and of course, it improves our life. And people, it's of course, I have to read a lot about the advancements of AI, because I teach elements of AI. For example, I am involved in actually developing politics of AI. It's called. It's a European Union document which actually talks about how we incorporate artificial intelligence into our daily lives. and into public institutions as well. So, but what is really important, Brian, when we study AI is ethics of AI. And this is a very, very important subject to talk about. And also I am involved in that area as well. And this is all so inspiring here being in Poland and meeting all these interesting people and scientists. And of course, when I talk about ethics of AI, I don't only talk to people that are mathematicians or are in data science, but to lawyers and lawyers, scientists, and together with them is, of course, we also work on another project which involves ethics of AI. Amazing and interesting, and I am so inspired, and I'm so happy that I can actually be in that field, because it never gets old, and it will only go will be developed further. I have so many students interested in doing data analysis and doing predictions from data, and they bring to me so many interesting topics and data sets. Oh, it's just amazing.
What a fascinating conversation we're having tonight with Dr. Ilona Urbaniak, who is an assistant professor at the Crombie University of Technology, about artificial intelligence. We're going to take a break and come back and chat with Dr. Urbaniak just a little bit more about artificial intelligence. Stay with us. Welcome back. We're chatting tonight with Dr. Ilona Urbaniak, who is an assistant professor at the University of Technology in Krakow, about artificial intelligence. And Dr. Urbaniak, I'm a little bit confused. Maybe you can help me. We were talking about machine learning and deep learning and neural networks. If you can, help me understand what the difference is between those and why it's important for me to know that.
So maybe because I gave you definitions before, but maybe now let's describe that different in terms of, for example, data dependency. So for example, when you have a deep learning algorithm, you would need a lot more data to train such model. In machine learning, you don't need as much data. So that's one of the first differences that comes to my mind in terms of like really differences. For example, so because you need more data for a neural network to train, of course, you will need a lot more computational power. And therefore you will need more training and more training time. So do you know how long it could take for a neural network algorithm to be trained, for example?
No,
do you have any idea?
I have no idea. How long would it take for a neural network to be trained?
I want you to guess.
3 days.
It could, yeah, but it could also last even months. So this is, whereas, for example, machine learning algorithms, they train faster, ranging even from a few minutes to a couple of hours, for example. Yeah, but during the test time, of course, they could take longer. So another difference is the problem solving technique, as I described before. So neural networks are a lot more complex, and machine learning are simpler. But the real question is maybe how actually the computer would learn automatically. And so
how does the computer learn?
Exactly. So maybe this is the best question to ask here. So the answer is data, Brian. The answer is data. So basically, you feed in the data having different attributes or features, right? And once the algorithm has learned and interpreted the data, which means it has trained itself, the algorithm then goes in the testing phase. And then without explicitly programming it, you input a test data point and expect it to give you some results. Okay, so this is, and then you feed that model with a new input and you expect a result based on the trained model that you have already worked with using your historical data.
You know, I did this fascinating course once where we talked about knowledge, and there was this path that one had to go through from data to information to knowledge to wisdom. Do you apply that in computers?
Oh, you mean the DIKW pyramid? Yes, of course I have. It describes a relationship between functional relationship between data, information, knowledge, and wisdom. And actually, when we think of it, it's very intuitive, because typically information is defined in terms of what? Data, of course, and knowledge in terms of information, and then wisdom, of course, in terms of knowledge. Yes.
No, but I think it's more than that, Ilona. I apologize. So data is, and I'm in finance, and that data would be just a raft of numbers. Information would be when you take that raft of numbers and you put it into a financial statement or an analysis or something like that. Knowledge is when you find something out because of that is a company's going bankrupt, or it's going to be successful, or it's going to grow, or something like that. And then wisdom is when you do it over and over and over again, such that you become wise about how that is going to be applying. And so what I'm suggesting is that artificial intelligence, computer learning would be similar, where historically computers were just about the data. And then they started doing a little bit about information. But with artificial intelligence, they're moving into the knowledge and wisdom area.
Right. So we make, of course, yes, we make decisions, basically intelligent decisions based on data. So basically, again, as you said, going from data to information. So these models are able to take us from the data and provide wisdom, which is a decision, intelligent decisions, intelligent inferences.
Now, you're one of the smartest people I know. You probably don't know this. Have you ever heard of Frank Zappa?
No.
Frank Zappa, you never heard of Frank Zappa, a rocker of days gone by? Had an interesting interpretation of this model, because he thought that the data, information, knowledge, wisdom didn't go far enough. And you might like this, because I know that you're a music performer and artist as well. He thought it should be data, information, knowledge, wisdom, and then beauty and art. And then he went further and he says beauty, art, and love. And I thought that was kind of interesting, that he took that paradigm and stretched it out even further. Anyway, I'll just leave that for you to contemplate, and you can come back to me. So you're teaching artificial intelligence. How do you teach artificial intelligence? Do you have courses on it?
Yes. So at the university, yes, I teach. Actually, recently I taught a course, Elements of Artificial Intelligence. And it was a very interesting course offered to international students at the program. The program is called Erasmus. And yes, of course, the teaching is online these days. But it was quite interesting, yes. And also I am an author and a presenter in the course that I did for the Institute NASC, and it is available online right now on the IT school. It's a government website. However, it is done in Polish. And I was inspired by one of the most popular courses on AI for non-technical people. It's called Elements of AI. Have you heard about this one? It's a fully free online course. And
welcome back to the Brian Crombie Radio Hour. We've been having a chat tonight with Dr. Ilona Urbaniak. She's an assistant professor at the Krakow University of Technology, and she's an assistant professor in the Department of Informatics in Division of Data Science, and she specializes right now in artificial intelligence. And she's been describing to us what artificial intelligence is, and it sounds really quite interesting. Dr. Urbaniak, I had a fascinating conversation with someone who thought that the fourth industrial revolution was going to be so material, change society so much, that having females participate in STEM, science, technology, engineering, and math programs was critically important. And she ended up giving $15 million of money to Concordia University to name a Department of Engineering and to support females in STEM sciences and activities, because she thought this was going to change the world, and that she was worried that too many females shied away from involvement in those technical, scientific, engineering areas. And she said that that females, if they don't step up and learn those areas and dominate those areas, will end up falling behind. You're, I understand, a musical performer as well. What motivated you to get involved in a PhD in applied mathematics. What motivated you to become an expert in artificial intelligence? And how do we motivate other females to follow in your footsteps?
So first of all, I have to tell you that I have actually a number of female students that are doing master's thesis with me in data science. So actually the number of female students studying in data science, specializing in data science, is rising every year. I see this since I have started to work at this university, for example. What has motivated me to study artificial intelligence, to study data science? So, and how I started with mathematics. This is the first question. So actually for me, it's kind of interesting because I combine art with science. And how do I do this? I think that all scientists are artists too, so we create. We have to come up with something new. This is a creation process. We have to make something new. We have to look a little bit away from whatever is standard and come up with something that has not been done yet. And it's the same with writing music, because I do write also lyrics as well as melody for my songs. So this is how also this creation process is so amazing and has always been something that I needed in my life. And so this is really natural to study, to go into a technical discipline. This is the question from you. So it was natural. I cannot tell you why. Mathematics has always been a natural direction for me to study. So I did computer science and then mathematics and then applied mathematics. Yes.
So if you were speaking to a group of high school students and they were asking you, is there a role for, an opportunity for females in computer science, in STEM activities, what would you say to them?
I would motivate them, of course. I would, of course, this is what I always do. I encourage people. I believe that everybody has a talent, and everyone has talent, and definitely women should not be afraid of technical disciplines. That's of course, maybe it used to be a kind of a stereotype that people were thinking that men only can be technical. No, I see more women in this technical areas doing amazing research. So yeah, always motivate.
And you said that music and science had some similarities, that your artistic capability and expertise and your love of math has some connection. Explain that. What's the connection between music and science, or music and math?
The music and math. Okay. So this is I don't know who said this, who's the scientist or philosopher or musician, I don't know, but it sounds like this. Music is subconscious counting. So it's kind of like humans, they appreciate order. They appreciate this sense of order, this counting, but music gives you this, we are unaware of the process of counting. Mathematics, of course, is I guess you're aware of doing some calculations, putting them in order, of the art of putting them in order, and this is what gives pleasure, for example, to a mathematician when we see a nice proof which contains so many ideas, so many elements in one line. This is amazing. We could look at that one line of equation and we just admire it for days, believe it or not. And of course in music somehow we are unaware of it, but we subconsciously count, so it's like kind of like a subconscious arithmetic. And in terms of also the artistic connection to what I do is the performance part of it. As a performer, and I've been singing since I don't remember how old I was, and writing songs, now teaching students, and it's a very similar experience, I have to tell you, and I'm really happy. Even during the pandemic time, I cannot perform, I cannot sing, but I can teach, and this is amazing.
Well, I'm sure that it must be a pleasure for your students to learn from you. So thank you very much for the contribution that you make to your students. And thank you very much for explaining artificial intelligence to us.
I would, from my position right now, I would encourage all the women that are interested in technical fields in general. Don't be afraid. There is no stereotype anymore. that exists, that women are not able to do technical studies, research. And I see a lot more actually. Every year I see a lot more female students do their MSc, master's degree in data science. So yes, definitely I would encourage, motivate. And just going back to what you said about Frank Zappa and how he has interpreted and extended the model, the pyramid and he has after knowledge, he said there's beauty, art, and love. Brian, exactly. This is my inspiration to study such areas, and especially become at the beginning when I studied mathematics. It's all beauty, and people should do what they really love. And I do what I love. I am also a singer, and I see an amazing connection between music and mathematics. So what I try to say, I really encourage all the women to do what they love, and don't be afraid, never.
You're a musical performer, a singer. You write songs. Do you think artificial intelligence, do you think computers will start writing music and start writing lyrics?
Yes. Basically, when we talk about harmonies, we talk about structures, and neural networks are able to put structures together. And yes, of course, there are AI systems that compose music, and actually you can access that on the internet. This is quite interesting. Yes, of course. But of course, as a musician, it gives me a lot of pleasure to do it myself, to sit down and come up with a melody, to write lyrics, because it's all the emotions that we put in. And I don't want actually an AI system to do it for me in that case. Yeah.
So tell me, some people are worried that they thought that machines were here to sort of be, equipment that we use. But now you're talking about these computers actually not only just having data and information, but being knowledgeable and wise and making decisions. So they're actually going to be making decisions, and sometimes decisions for us. And then maybe actually being creative and being able to write things and produce works of art. Are the computers going to replace us?
No, I do not want to think like this. No, I think of AI as making our life easier. It offers, as I said before, productivity, and because we computers are able to make faster calculations, and they are able to solve complex problems. Of course, they can do more than humans in certain areas. And what is interesting, that certain things, what is easy for us can be very difficult for a computer, and what is difficult for a computer can be very easy for us. And for example, grabbing an object and turning it around may be very difficult for a computer to perform, but for us it's easy. But it involves so many different tasks which we are not even aware of. And for example, for a human, it could be it is very difficult to perform very complex calculations. And whereas for a computer, of course, if computer is able to perform very fast calculations. So you see, what's easy for humans could be very difficult for computers, and what's difficult for computers could be very easy for humans. And I want to think of AI as improving life conditions, and as we talked about healthcare services as well, and in many different areas of life, and definitely it's a plus.
As I think I'm actually doing my part-time doctorate as well, because I just want to be a doctor like you, I guess. And it's in social capital.
Right.
And it's interesting because there is a famous Israeli anthropologist who's written a couple of books, Sapiens, and then another follow-on book called Homo Deus, that talked about humans and artificial intelligence. And he's got this interesting model that I think you might be fascinated with, because he applies it to computers and then says, but if people have learned about this, but we've forgotten about it. And we should apply it to people, because what it'll show is that we can be even more powerful in the future if we apply it. So what it says, and it's applied to computers to start with, but then think about it from a people. He said that the power of a computer is, number one, based on the number of processors. Number two, the connectivity between the processors. Number three, the diversity of the processors because they want to be different. And then number 4, the depth or the thickness of the connectivity between those diverse processors. And that defines this sort of neural network that you were describing. And he said that we understand that in regards to computers, but sometimes we forget about it in regards to humans. And he says, so therefore, if you think about it in humans, it's the number of people, it's the connections between those people, i.e. social capital or connectivity and stuff like that. Number 3, it's the diversity of those connections, because if we're all white Anglo-Saxon males or white Polish females, we're going to end up having one typical similar thinking process. And you actually want diversity. You want people from different sexes and different races and different religions, and we'll all mix together in different age groups. He argues that young can teach old and old can teach young. And then I love this last one, the thickness of our connectivity. In other words, we've got to have really good connections. We can't just sort of know each other. We've got to know each other really well. And I like that, because that really is a really good way of applying sort of neural networks and computers to social capital and people and communities and businesses and organizations and how we can be more successful. In other words, we have to have people, we have to be connected, we have to be diverse, and we have to have really good, strong relationships.
It is a fascinating analogy. Yes, when I listen to actually this interpretation and this analogy, yes, it's very, very interesting. Yes, definitely. Yes, and you seem to have quite a great understanding of how a neural network actually works.
Dr. Urbaniak, will our artificial intelligence, will the 4th industrial revolution change the world?
It is changing the world. It has been changing the world for many years, and yes, and it's very good news for us because our lives will be better.
Dr. Ilona Urbaniak, assistant professor in the University of Technology, Krakow. Thank you so much for being with us tonight and educating us a little bit about artificial intelligence. Really appreciate it.
Thank you so much. It's been a pleasure for me.
That's our show for tonight. I'm on every Monday through Friday at 7 o'clock on Saga 960. That's 960 on your AM dial, or you can stream me online at www.saga960am.ca, or you can get all my podcasts and video casts after the fact on briancrombie.com, on Apple Podcasts, on Spotify, on YouTube, anywhere you can actually get podcasts. You can get me under the Brian Crombie Radio Hour. It's been a pleasure chatting with Dr. Urbaniak tonight and thinking about how artificial intelligence could, and I think will, change our world. Good night, everybody. Good night, Ilona.
Thank you so much. Thank you. Good night.